Hello and welcome back to another episode of the Natural Number Game with Lean4. Today we're picking up right where we left off last time in the advanced proposition world. And we're going to start off with level 5. If and only if transitive Easter eggs. So for this we're going to try if and only if trans again, but we're going to prove this in some other ways to learn some new tricks with Lean4. So we're gonna prove the exact same thing in a couple of different ways, or with a couple new tricks. Okay, so we're gonna start the same way. Intro HPQ, HCharge, so it's a little clearer. So now initially we had P implies Q, or P if and only if Q implies Q if and only if R implies P if and only if R. And so we're going to introduce our two hypotheses, P if and only if Q, and Q only if and only if R. And then we're going to use our constructor tactic to split it into the two cases. So we have case MP and case MPR. And for our first case, we're going to intro P. And then here, instead of doing cases H1, cases H2, and so on and so forth, and getting P implies Q and Q implies P, what we can do instead is we can apply. What can we apply? We can get the well, pretty much with if and only if dot MP HQR and we can apply this. So this is Q if and only if R. This whole thing is Q if implies R. And so this would, you can see what MP does. For all A, B, or A and B propositions, A, if and only if B, if we take that as input, what we get as output is A implies B. And we also have a corresponding MPR, which, well, it doesn't work with this case, but it doesn't make sense with this call to apply, but this goes B implies A. And you can see this kind of matches with what the constructor gives us, case MP, case MPR. Nice. And now this takes us, so if we look through, we started with the original thing. After we introed, we got our two hypotheses, P if and only if Q, Q if only if R. We need to improve P if and only if R. We intro P. Oh, so you call constructor to split into P implies R and R implies P. For the first case, we intro P. Now we need to prove R, and we apply this. Then we need to prove P. Now we can apply if and only if MP H Q to prove P, and then we have exact P. So that's our first trick with start with if and only if. We have this if and only if dot MP, and then also corresponding if and only if dot MPR. Another trick is we can, instead of using cases, we can also use the rewrite tactic. So in this example, if we intro R, now we get P, so kind of now we're going to walk backwards. So we could prove this with MPR. Can we do it like this? Can we? Will this work? Yeah, so we could do it like this. R, just using the MPR, but different way we do is we can use the rewrite tactic to change this from P into Q and Q into R. So what does that look like? if dot mp hpq br. Oops, we should be using rewrite. Rewrite mp. Okay, so we want to go from, so we have intro, change our goal. Okay, we want to change this R. Okay, so we're going to do mp on hqr pr. Let's figure this out. Rewrite, and then we can just use let's see, hqr hpq. Okay, nice. So rewrite hpq. What does this do? This changes our goal from p to q in a similar way that apply changed our goal from R to Q. Here using rewrite. Rewrite can work on if and only if statements in addition to one-way implications. So we do this the first case, then we have HQR the second time, and then finally we have exact R. Nice, so that's a few different tricks on how to solve if and only if transitively using some different ways. So we can use the rewrite constructor, and we can use these functions if and only if.mp, if and only if.mpr. Let's move on and learn some new tactics or functions. Now we're gonna work on level 6 OR, and we're gonna prove, or I guess example, PQ prop Q implies P or Q by prop, not prod. Okay, here we have this function or.inr. So INR is our write injection into an OR. So pretty much it takes input B, where B is of type prop, and it returns A or B. So we need P or Q. We have Q, so this gets us P or Q, and we can see the type of ANSYS is P or Q. And that's and then this is also shorthand for intro write. So here we specify P explicitly, or we can have this be synthesized automatically with INR. Nice, that is injection to OR. Now we're gonna prove a new lemma. Lemma or symmetrical, P, Q are propositions. P or Q implies Q or P by intro PQ. I can do PQ dot exact PQ dot left Alright, don't know if this will work. Okay. Don't know if we have a constructor for propositions. Okay. Oh, okay, so OR has two constructors, so we cannot use anonymous constructor notation. What we can do is we can do OR dot elim where this says, okay, proof by cases on an OR. If A or B and both A and B imply proposition C, then C is true. Okay. OR dot elim on PQ. Let's think how to do this. Okay. So let me do some investigation on what the best way to go about solving this is. Okay, so for this one, so OR elim group by cases on OR. If A or B, both A and B imply proposition C, then C is true. So we have our case for elimination, PQ. So we're going to need to prove two different cases. The first case is expected to have type P implies Q or P. And the second one has case the next one needs to be Q implies Q or P. Okay, and the exact specifies that the output needs to be this. So pretty much for these, the input needs to be, first one is P, second input is Q, and both their outputs need to be Q or P. And let's see. Okay, so in our case, we have two functions that, well, this function takes something of B and proves A or B. So this satisfies our case of needing something that takes in P and returns Q or P. The second one takes in Q and returns Q or P. And so this whole thing is just Q or P because we have P or Q as our hypothesis, and using the left side of P or Q, P, we can prove P, Q or P. Using the right side of P or Q, we can prove Q or P. And so that combines with OR elimination to get us proof by cases on OR. And that's OR symmetrical. Nice. Since this episode is getting a bit long, I don't think I'll be able to finish the rest of the advanced proposition world. So today we did a bunch of advanced tactic stuff with if and only if and the or. Next time we'll do some stuff with and, as well as get to the law of the excluded middle. Thanks so much for watching.